Saturn V Quarterly Film Report Number 7 covers progress during the period June, July, and August 1964. Work on the S-1C stage by Boeing and Marshall continued during the report period. Preparation for structural testing of the S-1C test fuel tank was completed, and full-pressure hydrostatic testing was begun by Boeing August 4th at the Marshall Space Flight Center, but was interrupted when discrepancies in the test setup were encountered. Repair and rework of the test gear are in progress, and resumption of testing is scheduled for mid-September. Installation of the 5 LOX tunnels on the fuel tank of the S-1CT static firing stage was completed at Marshall on June 6th. Hydrostatic, calibration, and leak testing of the fuel tank began June 22nd and was completed July 20th. On June 15th, the S-1CT LOX tank half assemblies were welded together, completing the LOX tank assembly. Hydrostatic testing of the LOX tank started August 6th and was successfully completed on August 15th with minor rework required. Installation of the heat shield for the S-1CT thrust structure was started this quarter. The framework of the shield was completed in August and was installed on the thrust structure with panel installation scheduled for next quarter. Cylindrical skin assembly and bulkhead fabrication work continued on the fuel tank for the S-1CS. Structural test components. Assembly of components, principally bulkhead gore segments for the first flight stage S-1C1 got underway in June. The S-1C stage simulator has been cut into the forward and aft sections representing the LOX tank assembly and the fuel tank assembly respectively, and will be used next quarter in practice mating operations on the new horizontal assembly fixture scheduled for installation in September. Construction of Marshall's S-1C static test stand is nearing completion, with beneficial occupancy granted August 1st. Instrumentation equipment is now being installed in the control rooms of the blockhouse, which will serve both the S-1C and the F-1 engine static test stands. At Marshall's Michoud operations, Boeing's first S-1C production bulkhead neared completion. It will be used on the LOX tank of the structural test components vehicle being assembled at Marshall. By the end of June, gore-to-gore welding had been completed and instrumentation brackets spot welded into position. Bulkhead to Y-ring trim and weld were accomplished during July, and the unit was made ready for polar cap installation. Also at Michoud, Boeing assembled the first S-1CD fuel tank ring by welding together its 4 sections. And the ring was placed on this fixture for anti-slash ring baffle installation. Boeing S-1C component fabrication this quarter included emergency drain ducts for S-1C LOX and fuel tanks, and LOX tank cylindrical skin panels. At the Seal Beach facility of North American Aviation Space and Information Systems Division, S-2 stage manufacturing activities progressed steadily this quarter. In June, the S-2S structural test stage, common bulkhead forward-facing sheet was installed on a tracing fixture, and a vacuum bell was installed over the facing sheet. A vacuum was applied to draw the facing sheet to a smooth contour, and the inner surface of the facing sheet was traced or measured. The vacuum bell was then removed. Based on the tracing data, machining of the surface of the honeycomb core-covered aft facing sheet was accomplished. On July 30th, a major milestone was reached when the final bond on the S-2S common bulkhead was completed. Before bonding, 2 impression checks were made. Polyvinyl coating was applied over the honeycomb area. The forward-facing sheet, supported by the vacuum bell, was lowered onto the assembly, and a vacuum was applied between the 2 facing sheets. Prior to applying adhesive to the forward-facing sheet, vacuum was applied between the vacuum bell and the forward-facing sheet in order to remove canning or indentations. Adhesive film was applied to the inner surface of the forward-facing sheet after cleaning and priming. Supported by the vacuum bell, it was lowered onto the honeycomb core. After fitting and applying a vacuum between facing sheets, the vacuum bell was removed and the assembly placed in the autoclave for the bonding cycle to produce the first S2 common bulkhead. Welding of this bulkhead to cylinder number 1 and 2 subassembly and hydrostatic testing of this unit will be accomplished next quarter. The S2S thrust structure and aft skirt assembly was transferred to station number 3 of the vertical assembly building in June, and mating to the static firing skirt was accomplished. The liquid hydrogen forward bulkhead and liquid hydrogen tank cylinder number 6 assembly for the S2S was moved out of Station 2 in the vertical assembly building in early June and installed in Station 6, where hydrostatic testing of the assembly was successfully performed. Following hydrostatic testing, the mating of this assembly to the S2S forward skirt was accomplished in July. To attach the skirt, a total of 572 mating holes were located and drilled. Also during the quarter, the insulated LH2 quarter panels for the common bulkhead test tank were ultrasonically inspected for bonding deficiencies, with all panels proving satisfactory. At the S&ID cryogenic test facility at Downey, California, development qualification testing of the 1.6-inch thick helium-purged foam-filled insulation design for the S2-1, 2, and 3 was successfully performed in July. Major subassembly on the S2F facility's checkout stage started in late June with the installation of a gore segment on the common bulkhead aft-facing sheet meridian weld fixture. At the Santa Susana Static Test Facility, activation of the S2 battleship test stand continued. On July 29th, demonstration of the flame deflector water system was successfully accomplished. At Douglas Aircraft Company's Huntington Beach facility, additional instrumentation was installed on the S4B hydrostatic vehicle early this quarter at Marshall Center direction in order to provide more complete data in event of a rupture. On July 14th, structural damage occurred on the hydrostatic vehicle due to a weld failure during hydrostatic testing. The rupture occurred at 34 psig, 2 psig less than proof pressure. The liquid hydrogen tank could not be salvaged, but the LOX tank common bulkhead will be repaired and the LOX tank used in connection with structural testing of the thrust structure. By reduction and analysis of test data obtained prior to rupture of the hydrostatic tank, it was determined that it will not be necessary to resume hydrostatic testing on a future structural vehicle. The S4B dynamic vehicle was moved into insulation chamber number 1 in early June, and insulation was installed by mid-July. The all-system stage tank assembly has been completed and has been prepared for installation of cryogenic insulation. Assembly of the facility's checkout vehicle was completed in late August. At Douglas's Sacramento test area, work continued on the Beta and Gamma facilities. In June, the J2 engine was installed on the S4B battleship tank. As the report period ended, preparations were being made for cold flow and hot firing tests next quarter. Checkout of battleship ground support equipment continued at the Beta blockhouse. At the Gamma facility, the attitude control engines for the S4B auxiliary propulsion system were received from TAPCO in Los Angeles. The engines are being installed and testing will start next quarter. Engine number 12-1 this quarter became the first F1 engine to be equipped with the new rigid high-pressure propellant lines. These offer several advantages over the former design, being lighter, more easily fabricated, and providing a reduction in pressure drop by eliminating internal restrictions. To reduce turbine back pressure, a new turbine exhaust manifold inlet has been designed and fabricated by Rocketdyne. This configuration provides improved flow and pressure distribution to the manifold and nozzle extension. The first Block 2 heat exchanger has been received and will soon undergo testing. The new unit has a shell configuration which eliminates the shroud formerly used while maintaining the required gas flow velocity. The F1 engine O84D type injector is now undergoing development test. This injector design appears to meet the flight rating test specific impulse and other required characteristics. At the Edwards rocket engine test site, F1 engine test stand number 1D was activated in June. This is the first of 3 new stands which will be used for production engine acceptance testing. At the Marshall Center, propulsion testing on the second F1 production engine began on June 23rd and continued during the quarter in the modified S1 stage test stand, which includes a simulation of S1C tankage and ducting. Propulsion testing of the first production engine begun last quarter also continued. Construction of the F1 engine static test stand at Marshall is now virtually complete, with beneficial occupancy scheduled in September. Water flow checkout of the stand's deflector plate was performed on August 20th. Maximum flow is 136,000 gallons per minute. The first F1 engine firing on the new stand is set for mid-November. At Marshall's F1 turbopump facility, build-up and activation are in the final phases, and checkout has begun. The facility will provide a simulation of vehicle net positive suction head for both fuel and LOX for turbopump testing. Culminating a series of successful gimbaling tests begun last quarter, the Rocketdyne J2 engine has demonstrated its ability to meet preliminary flight rating test requirements for gimbaling during hot firing. This latest model gimbal assembly has gimbaled the J2 system in tests at the rate of 30 degrees per second to a maximum of 10 degrees. In initial altitude testing of the spark plug of the J2 engine's augmented spark ignition system, the plug was successfully operated in a vacuum environment to determine its characteristics in outer space. A corona effect is apparent as the plug operates through a 100,000 to 200,000 foot altitude range. Experimental studies to determine fuel flow uniformity of the J2 thrust chamber tubes were conducted by Rocketdyne this quarter in a high flow test chamber with 1,125 to 2,250 gallons of water per minute being pumped through the chamber. Rocketdyne assembly of flexible armored harnesses for all J2 engine electrical control and instrumentation harness wiring is underway. This will provide complete moisture protection, handling and abrasion protection, and short-term fire protection for the 14 individual harness assemblies in the J2 engine system. At the Marshall Center, construction of the J2 engine test facility is approximately 85% complete, with beneficial occupancy expected in November. The facility will be used to static fire single hydrogen-fueled engines with thrust ratings up to 200,000 pounds for test durations up to 500 seconds. Redesign of the Saturn V instrument unit structure necessitated by revised vehicle loads was completed in August. Structural units, such as the facility's checkout unit already delivered to the old design, will be used for tests not involving structural testing. Delivery of the first new IU structure to Marshall is due next quarter from General Dynamics, Fort Worth, Texas. At Marshall this quarter, a prototype of the heat exchanger which will be used in the instrument unit environmental control system underwent successful testing. The heat exchanger will provide temperature control for the IU equipment as well as for other instrumentation in the S4B stage just below, by cooling a water methanol solution which circulates through the cold plates to which the various instrumentation devices are mounted. Around the IU will be located 16 such cold plates, one of which is depicted in this cutaway drawing. Similar panels will be used for the S4B instrumentation. Made of brazed aluminum, each panel is 30 inches square and 1 1/4 inches thick. Contract negotiations are still in progress with International Business Machines, selected last quarter as prime contractor to take over development and fabrication of the IU. Meanwhile, IBM has gone forward with its efforts in facilities and personnel buildup at Huntsville. Prototype ground support equipment for the S1C stage electrical and mechanical test control stations underwent test and checkout by Boeing at the Marshall Center during the report period. Ground support equipment, systems measuring device test consoles, and electrical harnesses for S2 stages were being assembled and checked out during the quarter at SNID's Compton, California facility. The remote power distribution rack, the first major item of deliverable GSE, was shipped to the Santa Susana Static Test Facility on July 10th to support the battleship test program. At Douglas Aircraft Company's Huntington Beach, California Systems Integration Laboratory, checkout of the initial set of the S4B ground support equipment is nearing completion. The Systems Integration Lab vehicle simulator is also nearly finished. The simulator, which will include a J2 engine, will be used to prepare checkout tapes for checkout of flight stages. At Marshall's Saturn V ground support equipment test facility, brick and mortar construction is approximately 90% complete. The control room has been finished with beneficial occupancy granted August 1st. Installation of technical systems is scheduled to begin in September. Testing of various ground support equipment, such as this prototype S4B aft swing arm tip assembly, is being conducted for the Kennedy Space Center in temporary facilities at Marshall, while construction of the GSE test facility is underway. This prototype S1C tail service mast is another item being tested at Marshall to prove the design concept of Launch Complex 39 GSE. Construction work on the Saturn V dynamic test stand at the Marshall Center is now virtually finished, with completion scheduled in September. Marshall's 30 million pound capacity load test tower was practically completed this quarter, with beneficial occupancy granted the last week in August. Initial use of the new facility for structural testing of an S1C intertank is scheduled in September. At Marshall's Saturn V barge dock and loading facility on the Tennessee River, dry excavation for the dock is complete. Pile driving is about 90% finished, and the concrete work and pier have been started. Overall construction is approximately 40% complete. At Marshall's Mississippi test facility, construction continued this quarter at the 3 complexes. At the test complex, pouring of the foundation for the S1C dual position static test stand is approximately 25% complete. At the first S2 static test stand, foundation work is approximately 55% complete. Excavation has been completed at the second S2 stand, and pile driving is nearing completion. At the laboratory and engineering complex, construction continued on the office and administration building, data handling center, and telephone and terminal building. And at the support services complex, work progressed on such facilities as the emergency services building, MTF warehouse, site maintenance building, central heating plant, and electrical substation. The design stage of the first phase of the MTF technical systems is essentially complete. Contracts have been awarded for procurement of cable trays, instrumentation cables, and control cables. Installation of the system is scheduled to begin late this year. Work also progressed at Pascagoula, Mississippi, on modification of several government-owned barges and fitting them with barge tanks for transporting liquid cryogenics to be used at MTF. In summary, June, July, and August were months of substantial progress along a broad front of activities. Assembly of S1C stages gained momentum. The first S2 common bulkhead was completed. S4B ground stage assembly continued. And significant progress was achieved on the engine programs, the instrument unit, ground support equipment buildup, and facilities construction.